Okay, this is experiment 1.8, the sensitivity of a balance. This is a little pre-lab intro just to help you get through this lab successfully. It can be a little bit tricky. So you always want to make sure you have your textbook at your lab station. I'm just going to read through the book, answer the blue dots, and do exactly as the lab tells me to do. So the point of this lab is to figure out if you mass the same object several times on the same balance, will you find the same mass each time? And if we find a different mass, why? That's what we're trying to figure out today. So part of it says, if you mass the same object several times, will you find the same mass each time? So you're going to mass two objects, such as a penny and a stopper. And you should have one of these at each of your stations. Place the objects on the balance one at a time and have your lab partner read and record each result. Now switch roles with your lab partner and mass the two objects again. It says repeat this procedure as many times as specified by your teacher. So you're going to mass each object 10 times. I have a data table here. So you'll see it says mass of penny, mass of stopper, 10 trials. So you can each do the penny, one can do the penny, one can do the stopper, or you can do 5 of each, however you want to do it. These scales are pretty expensive, so we need to be careful with these. You never want to push down on this pan. You can ruin the little spring in there that's calibrated to help us get the correct mass of these objects. You don't want to set anything heavy on there like a textbook. We want to make sure we always close it and turn it off when we're done. So when you're massing these objects, you're going to first turn the scale on, and you have to wait. It kind of runs through a little startup process. As soon as you see the little scale in the corner and zeros, then you know it's ready to go. So I'm going to mass my stopper. So I'm at 13.74 grams. So I would record that in my data table, which you're going to have these in your notebook. I'm going to have you write these down in your notebook. Then I'm going to hit 0 so that I re-zero the scale each time. Then I'm going to mass my stopper again. 13.72 grams that time. You're going to record that, and you're going to do that 10 times for the stopper, 10 times for the penny. That part is pretty simple. Now, for the second question, how much must the masses of two objects differ before your balance is able to tell the difference between them? To answer this question, you can add small known masses to an object already massed on your balance. A set of such small masses can be obtained using the squares from a piece of graph paper. So here's the tricky part to this lab. It says, to obtain small known masses, cut a group of smaller squares from a large square of graph paper that you have massed. Begin by neatly cutting a large square of graph paper that has 20 squares along each edge. This large square is made up of 400 smaller squares, 20 by 20. So I'm going to give each station a piece of graph paper. There's enough for you to each cut out 2 squares that are 20 by 20. That's why you have scissors. You're just going to cut that out. So that's our 400 small squares. It says estimate the mass of the large square to the nearest 0.1 gram. So, and then it says you can write your estimate on the square and compare it with estimates made by your classmates. So take a guess. How much do you think this piece of paper is going to weigh? Write it on here. No right or wrong, just make a guess. Then it says now mass the large square. So I'm going to mass my large square. My large square is 1.03 grams. Now, second blue dot says what is the mass of your large square of graph paper? I just did that. So you're going to answer that for that second blue dot in your notebook in a complete sentence. Now it says, what is the calculated mass of a single small square? So this is just like our bell work question. except we have 400 small squares, and the mass of this piece of paper is 1.03 grams. So to find the mass of one of these little teeny tiny squares, we're going to take 1.03 divided by 400. And that equals 0.002575. So that is the mass in grams of one of these teeny tiny squares on this piece of graph paper. Now it says, for the purpose of this experiment, it will be convenient to have a rectangular piece of graph paper made up of small squares with a total mass between 0.003 and 0.007 grams. So one of my small squares is 0.002575. So I'm just going to times that by 2, and that equals 0.002575. Now all your numbers might be a little bit different depending on how you cut this out, what your scale says. So times 2, and that equals 0.00515, and that's grams. So that is in between the 0.003 and the 0.007 that the book wants me to find. So then it says, how many small squares, this is a blue dot number 4, how many of the small squares are in a group that has a mass between 0.003 and 0.007? So for me, that's 2. What is the mass of this group of small squares? That's blue dot 5. I just did that. Mass of 1 times 2 gives me the mass of 2 of those squares. These groups of squares are the known mass that you will add to an object massed on your balance. Prepare 10 of these groups. So now I'm going to cut out 10 groups of 2 little squares. So there's one. Oops. So there's my 2 little squares. So I need to cut out and make 10 of these. So I'm going to do that, and then it says, with a penny or a rubber stopper already balanced on the scale, add the groups of small squares one by one and observe the effect on the balance. So I'm going to add one group and see if there's a change. Now, here's the second data table that you already have in your notebook, and it says number of rectangles added. So these are the little rectangles. Yours might have 3 squares, it might have 2.5, depending on the mass of your big square. Then it says, was there a change in the mass reading? Right here, you're just going to write yes or no, and then you're going to tell me what the mass reading was. So for me, I'm at 13.73. It might take 4 of these rectangles to change the scale on the reading to 13.74. So in my table, it would say no, no, no. 4th one, if it changed, I'd say yes, and I would write down, record how much it changed by, what it changed the mass to. And it's probably going to be just by 0.01 grams. So once you get that data done, then we're going to be able to calculate the sensitivity of our balance using this data that we have. I will help you when we post lab probably the next day. After we get all of our data, we'll probably post lab the next day, and we will be able to calculate how sensitive our balance is. What is the smallest amount of mass that can create a change each time we add that small amount of mass?